All right, so confidence intervals for difference in means. All right, so I don't know if you guys remember the basic formula for the confidence interval when we just had one mean. Anybody remember? This is the one that's on the yellow sheet that you'll get on your exam. So it's the statistic plus or minus the critical value times the standard deviation of the statistic. So what's the statistic when we're doing means? X bar, good. And what was the critical value when we're doing means? T star. And you guys remember the basic formula for the standard deviation? Whoops. Yep. Yep. So Sx is the sample standard deviation divided by the square root of it. So that's like the formula when we just have one mean and we're not finding the difference. So let's see if we can find the formula for the confidence interval for the difference of means. So for the statistic, instead of X bar, what do you guys think it's going to be? Yep. We're finding the difference between two different sample means. Okay. Plus or minus. We're still going to find the T star. Okay, which means you need degrees of freedom. And the standard deviation formula we just learned yesterday, and it's the formula for standard error when you have 2, which is given to you on the formula sheet, except for it gives you, instead of the S, it gives you the O, but typically we use the S, right? The O is the population one, the sigma is the population one, and the S is the sample. So we're going to use the sample one. So you square it, and this is the first. That just represents the first sample standard deviation squared over N1, your sample size for the first sample. And the second sample standard deviation squared over N2. All right, so for most of your work, I'm actually just going to have you guys leave T star in the formula, and you're not actually going to calculate it, all right? We did calculate it before by inverse T. Do you guys remember that on the calculator? And you would plug degrees of freedom in. Now, if you do want to do this and give the more conservative answer, your degrees of freedom, n minus 1, you use the smaller of the two, all right? But we're probably just going to use our calculator, so I'm going to have you plug all these numbers in, but then use your calculator to do the confidence interval, which gives you T and P and degrees of freedom and all of that you write down, okay? All right, so let's try one. Big trees, small trees, short trees, tall trees. All right, like Dr. Seuss. All right, confidence intervals for difference of means. The Wade Tract Preserve in Georgia is an old-growth forest of longleaf pines that has survived in a relatively undisturbed state for hundreds of years. One question of interest to foresters who study the area is how do the sizes of longleaf pine trees in the northern and southern halves of the forest compare? To find out, researchers took random samples of 30 trees from each half and measured the diameter at breast height in centimeters. Here are the comparative box plots of the data and summary statistics from Minitab. All right, so in the north, we did 30 from each. We've got our mean in centimeters for the diameter and our standard deviation in centimeters. And they also gave us a box plot picture. So this says north on the top, all right, and there's our box and whisker, and south, box and whisker, and we've got centimeters on the bottom. So based on the graph and numerical summaries, write a few sentences comparing the sizes of longleaf pine trees in the two halves of the forest. So when it says to write sentences comparing, we're looking for socks. All right, back to like chapter 2 when we did socks. And you need to use comparison words. So make sure you're saying things like something is more than the other one or less than the other one. Use comparison words. Okay.
I found all the socks around.
Okay. I was like, what are we doing? All right, so shape. Raise your hand if you can tell me something comparing the shapes of the distributions. How about this guy right here? We've got a little extra space. That means it's skewed which way? Right skewed. All right. So the northern half has a right skewed distribution, and the southern half of the forest has a little bit of a left skewed distribution. So there would be something you could write about the shape. So the distribution of DBH measurements in northern sample is skewed right, while the DBH measurements in the southern sample is skewed left. Okay, so that was shape. Basically, you're talking about your symmetric or your skewed left or right. Okay, and then we've got, I did center next. So for the center of the graphs, raise your hand if there's something we could say comparing the center in the south to the center in the north. What do you think? Okay, yep, we've definitely got a higher median for the south than for the north. Another thing that's interesting is these are broken up by percentages. So if you just think about what percents, this guy has 75% of the graph above the northern's median line. Okay. So for the center, it appears the trees in the southern half forest have larger diameters because the mean and the median for the southern sample are both much larger. I think you really only have to compare one of those. If you just talk about the median, that's probably okay. And then they just mentioned the box plots show that more than 75% of the southern trees have diameters that are above the northern samples of the median. All right, and then spread. So for spread, think variability. Which one of those has more variability? What do you think, Ginger? Definitely the north, right? Look at the range. Which one has a bigger range? The north. Look at the IQR. Do you guys remember IQR? Yeah, from here to here is the IQR, Q3 minus Q2. That's a bigger distance than here to here. So both the range and the IQR are larger for the north, all right? Outliers, you would just say neither of them have outliers, okay? Oh, good. Let's construct a confidence interval. So back to our confidence intervals. So for the state part, we need to define our parameters. Are we talking about means or proportions? Means. Mean diameters, right? One's for the south, one's for the north. So you want to explain what that is. Be sure you always use the word mean or proportion when you're doing the definition. Some of you guys are skipping that. So mu1, and again, true mean for your parameters. Always use mu for the parameters and not x bar. So mu1, the true mean DBH of all trees in the southern half of the forest. And the other one is same thing but for the northern half. And since we're doing a confidence interval, we just wish to estimate the difference, mu1 minus mu2, at a 90% confidence level. So this is new. We're going to find the difference between the two. And we state our confidence level instead of alpha. That's for significance tests. Yeah. Yeah, I think you could say that. I think this implies it as well if you use mu, or, you know what I mean? But I think either way. Okay, what's the name of the test, you guys?
Two sample Z interval.
Good, 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 good. All right, you guys, it's two sample. It's T because we're doing means. So means are always going to be T. If we're doing proportions, we use Z. So two sample T interval for mu1 minus mu2. It's interval because we're doing confidence interval. Otherwise, it'd be test, right? Yeah. Yes. All right, since we have two different samples, what do we have to remember for random? Independent random samples. So we would say two independent random samples. Yeah, I don't mind. No, I don't mind. So we took 30 trees from the north and 30 from the south. All right, we have to check next the 10% condition. So what do you guys think? Do we have the 10% condition? So 30 times 10, there has to be at least 300 trees in each half of the forest, right? You got to check it for both. So you can say 30 is less than a tenth of all the trees in the South. You could also write it as we assume there are 300 trees, that there's at least 300 trees. And say it always for both, okay? I'll do this one in the north. And then we do large counts. So there's 3 ways you can check the population. This one doesn't tell us if the population is normal. So do we have large counts, though? What are both our sample sizes? The magic number of 30. So since both are 30, and N1 and N2 are both 30, we have large counts. And so now we can actually do the interval. Okay, so they actually gave us all the data, so we don't have to calculate it out. And so I'm going to do the greater one first to see if we get a positive number here. So I'm going to do 34.53, so our x bar minus our x bar, and just stay consistent with which is which. So plugging into the formula, which I do want you to show this lovely work, 34.53 minus 23.7 plus or minus. So what I want you to do here is leave it as t star, because we're going to find it on our calculator anyways. Okay, you could technically do inverse t and use 29 degrees of freedom, right? And if you do that, be sure you state that you used 29 degrees of freedom. And we multiply by our new formula that we just learned for standard deviation. And so you go back to your chart over here, and 14.26 is the first number, and we do that number squared. Divided by n, which is 30. And the other number they gave us for standard deviation is 17.5, which you square, divided by 30. So you must plug this formula in. I do want to see this. However, we are going to use our calculator to actually calculate it. So for our calculator part, you guys can go to 2 sample t interval under confidence intervals. You're on test. We don't want to test, right? All right, so go to calculate, menu, statistics. And this time we want confidence intervals, right? We're back to confidence intervals on this problem. And we have a 2 sample t interval. So the 2 sample z interval is when you know the population standard deviation, which is pretty much never. So 2 sample t interval. The other one we were using was for proportions. So t, since we're doing means. Okay, you can choose data or stats. Data is when you have a whole list. We already know the statistics, the mean, and all that. So go to stats. And we're going to go ahead and plug in. So x bar 1 is 34. That was the mean of the first one, 0.53. And the standard deviation was 14.26. And N1, our sample size is 30. Okay, the second mean was 23.7. And the second standard deviation was 17.5. And we also had a sample size of 30. And okay. All right, so the answer we're trying to find is this interval right here from 2.573. So our answer is 2.573. And there's a few things that you have to write down on this. 19.087. All right. So, you guys, you have to write down the degrees of freedom, okay? You're going to get a different answer if you actually calculate it all out and use a different degrees of freedom. This degrees of freedom comes from that crazy formula I showed you yesterday that you don't need to know. And so you do want to write down that your degrees of freedom that we used was 55.73 or something like that. Yeah. So 3.936, did you guys get that? 13.724. And degrees of freedom is 55. Same. Okay. All right, good. Sorry, you guys didn't scroll all the way down. And so then we conclude, of course, our confidence interval that you guys should have this pretty much memorized. We are 90% confident that the interval from, oh, weird, I have the right answer there, 3.936, 17 point whatever, centimeters. Okay, don't forget units. A whole lot of people forget units, and you maybe lost a point on that last confidence interval test for that. When you're doing means, you've always got units. Okay, so centimeters, that's how many centimeters. That captures the true difference in the actual mean dBH, so the diameter of the southern trees, and the actual mean dBH of the northern trees. So it's capturing the true difference between the southern trees and the northern trees diameter. All right. So the 90% confidence interval in the example does not include 0. So this is important to always think about. This gives us convincing evidence that the difference in the mean diameters of northern and southern trees in the Wade Tract Preserve isn't 0. That there is actually a difference, that it does matter. And the way we subtracted matters, right? So clearly the bigger one was, I think that was the southern one, okay? All right, so, however, the confidence interval provides more information than a simple reject or fail to reject the null conclusion. It gives us a set of plausible values. So they're trying to show you why confidence intervals might be better than significance tests, because you're getting an actual set of answers. So the interval suggests the mean diameter is between those two numbers, and it's that much larger than the mean diameter of the northern trees. Okay, if you switch the order of subtracting, so my numbers are backwards here, and my S's are, my standard deviations are switched, you still get the same thing except for negatives. It still means the same thing though, right? Since you switched orders, if you're getting negatives, that still means the northern trees are bigger than the southern trees. Okay, so don't worry about switching your order. Yeah, we're not doing that. Okay. You guys can help me.
So is there no 10.3 in this section?
No. I know, we're almost done. The only thing left we have to do is significance tests for means.
And that's
You guys basically know all this too, so that helps. I do 4 days of review, so Thursday. School days.
a week of
That's a lot. Yes.